everyone. Good morning. Yes, hello, good morning, Ayushi. Yeah, very good morning. So today we are going to talk about our next topic, that is our P block elements. Okay, in P block elements today we are going to talk about group 13 and 14 elements. Okay, you know group 13 elements. I have shared the screen as well as, am I audible to you? Yes, everyone, am I audible to you and my screen is visible? Okay, yeah, thank you for sharing your thoughts. Okay, so now let's start with our session. So today we are going to solve certain problems from P block elements. Okay, you know P block elements, they are what? Boron, aluminum, gallium, indium, and thallium. This is group 13 elements, right? And group 14 elements, which are those carbon, silicon, germanium, tin, and lead. Okay, this is group 13 and this is group 14. Okay, you know the atomic number 5, 13, 31, 49, 81, as well as the atomic number of carbon to lead. Okay, so these are the P block elements which we are going to talk about today, right? So now let's start solving the problems about these groups. Okay, first problem, very simple problem. The correct order of atomic radii in the molecule, okay, in the group 13 molecules or elements is what? Okay, so here what will be the order of atomic radius? So you know in the periodic table what is the atomic how the atomic radius changes? Yes, any answers? What will be the answer here? Correct order of atomic radius in the group 13 elements. What happens with the atomic radius in the periodic table? Whether it goes on increases, whether it goes on decreases. So here from boron, thallium, what is happening? The radius is increasing. Here boron to thallium, boron, aluminum, indium, gallium, and thallium. Here indium has been present here and gallium is present here. Okay, boron, gallium, aluminum, thallium, indium. This is the different. Okay, यहाँ पे aluminum पहले, ठीक है, यहाँ पे एल्यूमिनियम, इंडियम, गैलियम एंड थैलियम, ये जो मैंने यहाँ पे दिखाया ना, बोरॉन, एल्यूमिनियम, गैलियम, इंडियम एंड थैलियम. So what do you think which will be the order here? So as we move down, the radius go on increases. Boron, aluminum, gallium, indium, and thallium. Right? So boron, aluminum, gallium, and thallium. So यहाँ पे आयुषी आपने बताया कि आंसर A होगा, लेकिन see here what happens is atomic radii in group 13 elements, it increases according to this. Okay, boron, then gallium, then aluminum, then indium, and then thallium. Because when we talk about the atomic radius, now we need to consider the nuclear charge also. We need to consider the nuclear charge also, as well as the orbitals, d orbitals, which are entering into a given molecule. So because of that, our option D will be the correct answer, right? Next, AlF3 is soluble in HF only in presence of Kf. It is due to the formation of. So AlF3 is a molecule which is soluble only in HF, but in presence of Kf. So what do you think? What is the answer? So यहाँ पे देखो, do you have any answers about this question? See here, what happens is in AlF3 is insoluble in anhydrous HF. Okay, AlF3 जो है हमारा वो क्या है? Insoluble हो जाता है in anhydrous HF because of the F minus ions which are not available in hydrogen bonding with HF molecule. Okay, because ये जो F minus ions है यहाँ पे इस AlF3 molecule में, those are not available for hydrogen bonding with HF. Okay, but they become soluble in presence of little amount of Kf. But if Kf is present, then these F minus ion becomes soluble in the given solution when less amount of Kf is present. Why? Because due to the formation of complex K3AlF6. Because due to the formation of complex K3AlF6. So AlF3 is soluble in HF only in presence of Kf. Why? because it is due to the formation of a complex. Which is that complex? This is not the complex. Yeah, this is the complex. So our option is what? Option B. Okay, this was the question. AlF3 molecule जो है हमारा, that was soluble in HF, but only and only in presence of Kf. Why? Because F minus becomes soluble, right? Any doubts regarding this question? Yeah. Let's move on to the next problem. The solubility of +1 oxidation state among aluminum, gallium, indium, and thallium increases in the sequence. Yeah. So यहाँ पे not solubility, sorry, stability. So here we need to talk about the stability of the oxidation states. So here in group 13 elements, okay, for group 13 elements, as we can talk, is that for group 13 elements, stability of +3 oxidation state decreases as we move down the group, while that of +1 oxidation state go on increases due to the inert pair effect of the lower elements. Okay, hence stability of +1 oxidation state increases in the sequence. So +1 क्या होता है? As we go down the group, it goes on increases. So नीचे वाले जो है वो +1 ही ऑक्सीडेशन स्टेट दिखाते हैं मोस्टली. सो नीचे वाले कौन से? हमारा थैलियम, इंडियम, गैलियम एंड एल्यूमिनियम. सो यहाँ पे इंडियम पहले हुए, ये नहीं होगा. ओके, थैलियम यहाँ पे पहले हो गया, वो नहीं होगा, मतलब सबसे कम नहीं होगा ना. तो यहाँ पे एल्यूमिनियम आ रहा है, ये भी नहीं है. तो हमारा ऑप्शन क्या है? ऑप्शन ए इज द करेक्ट ऑप्शन. ओके, एनी डाउट्स रिगार्डिंग दिस एवरीवन? +1 ऑक्सीडेशन स्टेट. सो ऊपर वाले जो है दे शो +3 ऑक्सीडेशन स्टेट. But as we move down the group now, what happens is the +1 oxidation state go on decreases. Okay, it go on decreases, and +1 oxidation state go on increases. Right? Any doubts regarding this? Okay, let's move on to the next problem. Aluminium 3 chloride forms a dimer because of aluminium. Because aluminium belongs to third group. Because aluminium can have higher oxidation number. Because aluminium cannot form a trimer. And because it has high ionization energy. So you must be knowing about AlCl3 molecule, that is aluminium chloride. You know that it is present in terms of its dimer. It is present in terms of its dimer. So why is it forms a dimer? Why does it forms a dimer? Because it belongs to third group? No. Because it has a higher ordination number? Yes, this is our answer. Why? See, aluminium, due to the presence of 3d orbital in it, due to the presence of 3d orbital in it, it can expand its octet. It can expand its octet. Okay. And due to the expansion of its octet up to 6, from 3 to 6, it can form a molecule with higher oxidation or with higher coordination number. With higher coordination number. And that's why it forms a dimer. And that's why it forms a dimer. Okay, so aluminum atoms, to complete their octet, it forms its dimer. ठीक है, तो यहाँ पे देखो मैंने आप लोगों को एक्सप्लेनेशन दिया हुआ है. यहाँ पे you can see that this is our molecule AlCl3, okay, which is a dimer, which is present in the form of dimer. Here you can see aluminum is attached to a how many chlorine atoms? Okay, in order to complete its octet, it can connect or it can attach with the different number of chlorine atoms. Okay, 4 to 6 number of chlorine atoms it can attach. So यहाँ पे आप देख रहे हो एक aluminium को 4 chlorine atom attached है, right? In order to complete the octet, it forms a dimer. That is the very important. But how it can form? Because it can expand its coordination number. So option B is correct answer here, right? Any doubt regarding this? Okay, let's move on to the next problem. Which one of the following element is unable to form MF6 3- ion? Yeah, gallium, aluminum, boron, and indium. So this is very simple problem. Just now we have talked that as we move down, what happens is that the +3 oxidation state go on decreases. So यहाँ पे हम लोगों को ये कहा गया है कि the element which will be unable to form MF6 3- ion. So MF6 3- ion means what? There are what? 6 ligands attached to a central metal atom. Okay, 6 ligands are attached to a central metal atom. So right now we have seen that aluminum can add up to 4 to 6 ligands to itself. Okay, so that's why it will be able to form the ion like this way. okay, because of the presence of 3d orbitals. So as we move down now from below boron, all are having 3d orbitals. So that's why they will be able to form the ion like this way. But boron, due to here there are no any vacant d orbitals present in its valence shell, so it cannot be able, okay, it cannot be able to extend its valency, okay, to extend its valency to more than 4 atoms, okay, to more than 4 atoms, okay, or 4 ligands, we can say that. So that's why boron cannot form the ion like this way. So that is our answer. So this is not able. ठीक है, दिस इज नॉट एबल, और वही पूछा था नॉट एबल कौन से नहीं होंगे, तो आवर करेक्ट आंसर इज बी, राइट. एनी डाउट्स रिगार्डिंग दिस? All are having vacant d orbitals, that's why they can expand their coordination number, but boron doesn't contains any vacant d orbital, and that's why it cannot expand its coordination number, and that's why it cannot form such type of ion. Okay, right, everyone. Next problem, the tendency of BF3, BCl3, BBr3 to behave as Lewis acid decreases in the sequence. So this is very important problem. In most of the exam, most of the time this problem is asked. ठीक है, so tendency of BF3, BCl3, BBr3, तो यहाँ पे see to behave as Lewis acid decreases in the sequence. तो Lewis acid जैसे ये behave करते हैं बोरॉन के सारे हेलाइड्स, we know this, but उनकी जो टेंडेंसी है ना लेविस एसिड जैसे बिहेव करने की, वो किस तरह से डिक्रीज होती है? BF3 सबसे कम है, देन BCl3 है, देन BBr3 है. इनमें से कौन सा ऑप्शन करेक्ट है, दैट वी नीड टू फाइंड आउट. सो हियर BF3, then BCl3 and BBr. So this order is correct. Why I am telling you this order is correct? So because when we talk about the relative acidic character of boron trifluoride, we found that this will be the order, that is BBr3 or BCl3 or BF3. Why? Just we have seen that आयुषी D. किसका आंसर बताया आपने ये बेटा? यही क्वेश्चन का आंसर बताया गया नहीं? देखो हमारा आंसर क्या हो जाएगा, बी आंसर हो जाएगा. ठीक है, आपका बराबर था कि आपने ये आंसर बताया, लेकिन दिस विल बी द नॉर्मल, मींस नॉर्मली वी कैन से दैट दिस विल बी अ गुड Lewis acid, right? But here what is happening is, here we need to consider the different kind of bonding. Okay, that's why this is not correct answer. So here the order will be this, in this way, but expected order on the basis of electronegativity of halogen should be like this way, like Ayushi, like you have explained or you have told me right now. ये होनी चाहिए order, लेकिन वैसे नहीं है. Why? Because it is showing anomalous behavior. What is happening? It is showing the anomalous behavior on the basis of the relative tendency of halogen atom to back donate its utilized electron to vacant p orbital of boron atom. तो यहाँ पे जब हम बोरॉन और फ्लोरीन लिखते हैं, तो यहाँ पे हम कुछ ऑर्बिटल्स ड्रॉ करते हैं. तो यहाँ पे जब हम वी ड्रॉ द ऑर्बिटल्स ना, you can see that boron cannot back donate its electron to the p orbitals of boron. Fluorine cannot back donate to the p orbitals of boron. Okay, 2 p orbitals of boron. So these are 2 p orbitals of fluorine, these are 2 p orbitals of boron, but the fluorine cannot transfer the electrons to the vacant 2 p orbitals of boron. Thus, it cannot form the p-pi bond. Okay, so यहाँ पे क्या हो रहा है? In BF3, boron has vacant 2p orbital and each fluorine has fully filled unutilized 2p orbitals. ठीक है, बोरॉन पे क्या है? वैकेंट ऑर्बिटल से, और फ्लोरीन के पास क्या है? फुल्ली ऑक्यूपाइड है, इलेक्ट्रॉन्स खचाखच भरे हुए ऑर्बिटल्स. सो हियर व्हाट हैपेंस इज फ्लोरीन ट्रांसफर्स 2 इलेक्ट्रॉन्स टू वैकेंट 2p ऑर्बिटल. तो यहाँ पे क्या हो रहा है देखिए, सो फ्लोरीन ट्रांसफर्स, सॉरी मैंने पहले बताया कि वो ट्रांसफर नहीं करेगा, तो देखो यहाँ पे क्या हो रहा है, इट विल ट्रांसफर. ओके, फॉर अदर देयर विल बी नो ट्रांसफर. सो it is going to transfer the electrons present in its 2p orbital. Okay, it is going to transfer its electron present in the 2p orbital. It can back donate. Okay, it can back donate, but certain halogens do not have a tendency to back donate. Okay, so fluorine transport 2 electrons to this vacuum to be orbital, and due to which there is a formation of p-pi bond. It is a formation of p-pi bond like this way. This type of bond has some double bond character and it is known as dative or back bonding. All the three bond lengths are same here. All the three bond lengths are same here. But it is possible when double bond is delocalized. So this delocalization is represented like this way. So delocalization भी आप देख सकते हो कि इस तरह से वो delocalization होता है. किस तरह का? इस तरह से. So the tendency to back donate goes on decreases from fluorine to iodine. ये जो tendency है ना back donate करने की, वो for bromine, for iodine, वो cannot back donate because of it goes on decreases because of the difference between the boron and halogen atom. Okay, because the distance between the boron and halogen atom go on increases. That's the BBR. Okay, then BI, the distance go on increases. Okay, यहाँ पे boron और fluorine में का जो distance था, that was very close because of the radius of the fluorine being smaller. But as we move down, the radius go on increases for a given element, and that's why here the back bonding is not possible because the distance becomes more, right? So that's why halogen order of Lewis acid strength for the given boron halides is like this way: BF3, then BCl3, then BBr, right? ये नहीं होगा ऑर्डर हमारा ऑर्डर होगा ये. समझ में आई ये बात? BF3 में क्या हो रहा है? It is showing back donation, and that's why it is not a good Lewis acid, right? BBA3 on the other hand is very good Lewis acid, right? Any doubts regarding this? Yeah. Next problem, boron compounds behave as Lewis acid because of their, why do they behave as a Lewis acid? What is the property of Lewis acid? Everyone, can you tell me why they behave as a Lewis acid? Which are Lewis acid? Electron pair acceptor or electron pair donor? Yeah, they are what? Electron pair acceptor or electron pair donor? Yes, Lewis acids are what? Electron pair acceptor or electron pair donor? So Lewis acid are what? They accept the electron pairs. That's why they known as a Lewis acids. Okay, so Lewis acids are those substances which can accept a pair of electron, and boron compounds usually are what? Deficient in nature. Boron compound क्या होते हैं? They are electron deficient in nature, and that's why they behave as a Lewis acid. So they have, because of their ionization property, because of electron deficient nature, because of acidic nature, because of covalent nature. So इनमें से कौन सा आएगा हमारा आंसर? B. तो वो क्या करते हैं? इलेक्ट्रॉन, लेविस एसिड जो है वो इलेक्ट्रॉन पेयर एक्सेप्टर होते हैं. जो डिफिशिएंट होंगे वही एक्सेप्ट करेंगे ना, जिनके पास ऑलरेडी है वो क्यों एक्सेप्ट करेंगे इलेक्ट्रॉन? सो दिस इज व्हाट? इलेक्ट्रॉन डिफिशिएंट इन नेचर, एंड दैट्स व्हाई इट acts as a Lewis acid. Very good. Next problem, boric acid is an acid because its molecule contains a placebo H plus ion, gives a proton, accepts OH minus from water releasing proton, combines with proton from water molecule. So here this example, this problem is very good problem actually. So boric acid behaves as an acid. Why does it behaves as an acid? Because you know right now just I have told you that Lewis acid क्या होते हैं? It accepts the electron. Okay, so boric acid accepts the pair of electron from OH minus ion of water, and thereby it releases a proton. So here option C is the correct answer. So boric acid क्या करते हैं? OH minus से इलेक्ट्रॉन एक्सेप्ट करते हैं और वाटर में प्रोटॉन रिलीज करते हैं. ठीक है, इसलिए वो अच्छे एसिड होते हैं. नेक्स्ट, विच ऑफ द फॉलोइंग स्ट्रक्चर इज सिमिलर टू ग्राफाइट? सो ग्राफाइट का स्ट्रक्चर किसके साथ सिमिलर है? ग्रुप 13 एलिमेंट्स, B4C, B2H6, boron or Bn. So we know this is also having a structure inorganic graphite and has a similar structure with the graphite. Bn को क्या बोलते हैं हम लोग? इनऑर्गेनिक ग्राफाइट. ओके, एंड ग्राफाइट क्या होता है हमारा? ऑर्गेनिक ग्राफाइट, जिसमें कार्बन होता है, राइट, which contains carbon. So Bn is an inorganic graphite which has a similar structure like graphite. Okay, next, what is the type of hybridization of boron in diboron? So this is very important question again. A, B, C, D. What is the hybridization of boron in diboron? That is B2H6. Yes. So here see, when we talk about B2H6, B2H6, it has a structure like this way. B2H6, you know the structure of B2H6? Yes. Like just we have seen for AlCl3 now. Similar to that, the B2H6 molecule is present. Okay. Similar to that, B2H6 molecule is present like this way. So this is the structure of B2H6 molecule. Here in each boron atom in diborane is what? sp3 hybridized. Okay, so everything is sp3 hybridized. Every boron atom is sp3 hybridized. There are two boron atoms, 1 and 2. So both are what? sp3 hybridized. Of the 4 hybrid orbitals, so यहाँ पे जो 4 हाइब्रिड ऑर्बिटल्स हम लोग यूज करने वाले हैं बोरॉन के आजू बाजू के बोरॉन के, ठीक है. सो दोज 4 ऑर्बिटल्स, देयर आर 3 हैव 1 इलेक्ट्रॉन ईच व्हाइल 4th ऑर्बिटल इज एम्प्टी. तो यहाँ पे एक इलेक्ट्रॉन सब में है, क्योंकि बोरॉन का इलेक्ट्रॉनिक कॉन्फिगरेशन अगर हम लोगों ने देखा तो 1s2 2s2 एंड 2p1. दीज आर द फिक्स्ड डिपॉजिट व्हिच दे कैन नॉट यूज. दीज आर द 3 इलेक्ट्रॉन्स व्हिच आर प्रेजेंट इन द वैलेंस शेल. सो दैट्स व्हाई each orbital is having the 3 electrons, okay, but 4th one is the empty. Okay, so 2 orbitals of each form sigma bonds. Okay, यहाँ पे हमारा आ गया हाइड्रोजन, यहाँ पे हमारा आ गया हाइड्रोजन. So 2 orbitals of each hydrogen forms here the sigma bond with the boron atom, while one of the remaining hybrid orbital, either filled one or the empty one, okay, that connects with the 1s orbital of hydrogen atom. तो यहाँ पे फिर से हाइड्रोजन एटम के साथ इसकी बॉन्डिंग होगी. एंड वन ऑफ द हाइब्रिड ऑर्बिटल्स ऑफ अदर बोरॉन एटम. तो यहाँ पे ये बोरॉन आ गया हमारा, इसके पास भी ऐसे इलेक्ट्रॉन है, ठीक है. यहाँ पे है, यहाँ पे है, यहाँ पे है और यहाँ पे, ठीक है. तो मैं क्या कर रही हूँ कि यहाँ पे मैं इलेक्ट्रॉन नहीं लूंगी, ठीक है, और मैं क्या करूंगी, वो जो इलेक्ट्रॉन्स है वो यहाँ पे डालूंगी. देखिए 1 2 और 3, ठीक है. और यहाँ पे हमारा आ गया हाइड्रोजन. हाइड्रोजन कैसे डालोगे तुम लोग? इस तरह से, ठीक है. तो बोरॉन 1 2 3 4, बोरॉन 1 2 3 और 4, और यहाँ पे आ गया हाइड्रोजन, और यहाँ पे है हाइड्रोजन. हाइड्रोजन 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 की कैसे होती है? एस ब्लॉक ना, एस इलेक्ट्रॉन, इसलिए गोल दिखा रही हूँ, ठीक है. स्फीयर, सर्कुलर इन शेप, ठीक है. एनी डाउट्स रिगार्डिंग दिस? सो यहाँ पे है एक इलेक्ट्रॉन, एक इलेक्ट्रॉन, एक इलेक्ट्रॉन और एक हाइड्रोजन का एक एक. इस वजह से ये बॉन्ड फॉर्म हो रहा है सिग्मा बॉन्ड, ठीक है. यहाँ पे ये बोरॉन का वैकेंट है, तो यहाँ पे ये बोरॉन है और ये हाइड्रोजन. ये बोरॉन का है, हाइड्रोजन का है, ये बोरॉन का है, हाइड्रोजन. मतलब ये मैं यहाँ पे ना दिखाते हुए मैं बाहर दिखा रही हूँ आपके समझ के लिए, ठीक है. तो इस तरह से ये बॉन्डिंग फॉर्म होती है. सो हियर एग्जिस्ट 2 टाइप्स ऑफ सच 3 सेंटर्ड डबल बॉन्ड्स. तो यहाँ पे क्या हो रहा है? 3 सेंटर है. किस तरह के 3 सेंटर है? देखिए यहाँ पे 3 सेंटर दिखाए मैंने, 1 2 और 3. ये हाइड्रोजन 3 सेंटर है, लेकिन 3 सेंटर के इलेक्ट्रॉन्स कितने हैं? 2. सो दिस इज 3 सेंटर 2 इलेक्ट्रॉन बॉन्ड इज फॉर्म इन व्हाट? B2H6 molecule. Okay, 3 centered and 2 electron bond is formed between B2H6 molecule, and such a bond is also known as banana bond. Okay, it is also known as banana bond and it is shown like this way. तो यहाँ पे ये इस तरह से हम दिखा सकते हैं बनाना बॉन्ड, ठीक है. इस तरह से हम इसको दिखा सकते हैं. तो इनको कहते हैं हम बनाना बॉन्ड, ठीक है. इस तरह से हमारी जो बॉन्डिंग है डायबोरेन मॉलिक्यूल में होती है. On B2H6 molecule, several times in examination questions has been asked so far. So please try to understand throughout the concept of B2H6. Okay. Next, which of the following statement about H3BO3 is not correct? So यहाँ पे we need to find out which statement is not correct. It has a layer structure in which planar BO3 units are joined by hydrogen bonds. It does not act as a proton donor but act as a Lewis acid by accepting hydroxyl ion. It is a strong tribasic acid and it is prepared by acidifying in aqueous solution of borax. So when we talk about this H3BO3 na, we need to find out which is not correct. So let's see. H3BO3 क्या है? It is not a strong acid, but it is what? Weak acid. बट यहाँ पे बोला है कि ट्राइबेसिक एसिड है, वो ट्राइबेसिक नहीं है. इट इज ओनली एंड ओनली मोनोबेसिक एसिड. हाउ? सो BO3 जो है वो क्या करता है? H+ सिर्फ एक ही देता है वाटर के साथ जब रिएक्शन होती है तो, ठीक है. सो दैट्स व्हाई इट इज अ वीक मोनोबेसिक एसिड. It is not strong tribasic acid. So that's why this statement is not true, and not true ही हम लोगों को find out करना था. Other statements are true, true and true. Okay. Yeah. Next. Which of the following statement is incorrect? Again, we need to find out the incorrect statement. SnF4 is ionic in nature, PbF4 is covalent in nature, SiCl4 is easily hydrolyzed, and germanium is more stable than germanium halide. So here we have started with the group 14 elements, okay, problems, group 14 elements. So here we can see that which of the following is ionic in nature, okay. तो incorrect हम लोगों को statement देखना है, okay. तो group 14 में as you go down ना, you can see that PbF4 and SN4 are exceptions which are ionic in nature. So these are what? Ionic in nature. Other compounds are what? Covalent in nature. So SnF4 is ionic in nature, PbF4 is covalent in nature. तो ये क्या हो गया? ये गलत स्टेटमेंट हो गया क्योंकि PbF4 और SN4 दोनों भी क्या है? आयोनिक है. So that is a what? Incorrect statement. Okay, SiCl4 is easily hydrolyzed. This is correct statement. Germanium halide is more stable, means tetrahalide is more stable than dihalide. This is again what we can say that true, 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 and true. Okay, this is false. That's why which we need to find out. So our option B will be correct answer. Next question: which of the following species is not stable? So which species is not stable here? So when we talk about the here first molecule, second molecule, third molecule, and fourth molecule, you can see that SiCl6 2-, this compound is not stable. Why? Because of the steric hindrance by large size of silicon, sorry, large size of chlorine. यहाँ पे क्लोरीन का जो साइज है उसके वजह से ये जो स्पीसीज है दैट इज नॉट स्टेबल, okay, because of the steric hindrance arises due to the large size of chlorine atom. So answer A is the correct answer. Next, it is because of, next question, it is because of instability of NH2 electron of the valence shell to participate in the bonding that Sn plus 2 is oxidizing while Pb4 plus is reducing. Sn2 plus and Pb2 plus both are oxidizing and reducing. Sn4 plus is reducing while Pb4 plus is oxidizing and reduce. Sn2 plus is reducing and B4 plus is oxidizing. So यहाँ पे हम लोगों को देखना है कि it is because of inability of NH2 electrons of valence shell to participate in bonding. ये जो इनएबिलिटी हो रही है, इनर्टेस हो रहा है एस इलेक्ट्रॉन्स का, वो पार्टिसिपेट नहीं कर रहे हैं बॉन्डिंग में, उस वजह से हमारा जो Sn2 प्लस है और हमारा जो Pb4 प्लस है ये आयंस कैसे एक्ट करते हैं, whether they oxidizing, reducing, in that way. So here you can see the inertness of S subshell electron toward bond formation. Such effect is known as what? Inert pair effect. So when S electron does not participate in the bonding, such an effect is known as inert pair effect. S subshell की electron जब bond formation में participate नहीं करते उसको हम inert pair effect कहते हैं. This effect go on increases as we move down the group. So for Sn, +4 oxidation state is more stable, whereas for lead, +2 oxidation state is more stable. Okay, for Sn4 plus oxidation state is more stable, and for Pb +2 oxidation state is more stable. This is happening for group 14 elements. Okay, this is happening for group 14 elements, sorry, not group 13. ठीक है, तो यहाँ पे 4 प्लस है और यहाँ पे Pb2 प्लस है, क्योंकि जैसे जैसे हम लोग नीचे जाते हैं, मैंने आप लोगों को ग्रुप 30 में बताया कि +3 ऑक्सीडेशन स्टेट क्या होती है, डिक्रीज हो जाती है, और +1 ऑक्सीडेशन स्टेट हमारी बढ़ती जाती है जैसे जैसे हम लोग नीचे जाते हैं. दैट वाज हैपनिंग फॉर 13 एलिमेंट्स, 13 ग्रुप के एलिमेंट्स. 14 में क्या होगा, +4 ऑक्सीडेशन स्टेट गो ऑन डिक्रीजेस एंड +2 ऑक्सीडेशन स्टेट गो ऑन इंक्रीजेस. सो बिकॉज ऑफ दिस व्हाट हैपेंस इज दैट Sn2 प्लस एक्ट्स एज अ रिड्यूसिंग व्हाइल Pb4 प्लस as a oxidizing. ठीक है, Sn2 plus acts as a reducing while Pb2 plus acts as a oxidizing in a nature. That is what during the formation of bonding. During the formation of bonding. ठीक है, तो यहाँ पे Sn2 plus क्या होता है, रिड्यूसिंग नेचर में एक्ट होता है, और Pb4 plus क्या होता है, ऑक्सीडाइजिंग जैसे एक्ट होता है. What is reducing and oxidizing? Can you tell me? Yes. या रिड्यूसिंग जैसे एक्ट करेगा मतलब वो क्या करेगा, इलेक्ट्रॉन दे देगा या इलेक्ट्रॉन ले लेगा. रिड्यूसिंग, व्हाट do you mean by reducing and oxidizing? So reducing means what? Yes, it will reduce other substance and itself undergo into oxidation, right? Itself undergo into ऑक्सीडेशन, इलेक्ट्रॉन डोनेट करेगा, इलेक्ट्रॉन डोनेट करेगा, या वेरी गुड, ऑक्सीडेशन में जाएगा मतलब लॉस ऑफ इलेक्ट्रॉन होगा, वेरी गुड आयुष. Okay, so this is the correct answer, option D. Next, which of the following oxidation states are the most characteristic for lead and tin respectively? So right now we have talked that as we move down, what happens is +3 oxidation state go on decreases and +4 oxidation state go on decreases and +2 oxidation state go on increases. So यहाँ पे हम लोगों को lead और tin के लिए बात करनी है, ठीक है. So यहाँ पे when we talk about the lead and tin molecule, you can see that here germanium, tin and lead of group 14 have tendency to form +4 and +2 oxidation state. ठीक है, मैं यहाँ पे लिखती हूँ कार्बन, देन है हमारा सिलिकॉन, देन है हमारा जर्मेनियम, ओके, देन है हमारा टीन एंड देन है हमारा लेड. Right, so this is our arrangement. So +4 is fine for this molecule, +4 is fine for this molecule. But as we move down, there is an inert pair effect in which the s orbital electron does not participate in the bonding, and due to this inert pair effect, germanium, tin and lead, these are the group 14 elements, they have tendency to form both +4 as well as +2. So sometimes what happens now, the s orbital take part in the reaction, sometimes the s orbital does not take part in the reaction. So now the inert pair effect increases down the group, hence the stability of this molecule also increases. So characteristics, oxidation state for lead will be what, +2, and for tin it will be what, +4. Okay, 14 it will be what, +4. Okay, next, carbon and silicon belongs to the fourth group. The maximum coordination number of carbon in commonly occurring compounds is 4, whereas that of silicon is 6. This is due to, so here carbon and silicon we are talking about. यहाँ पे I have written carbon as well as silicon. So belong to fourth group, मतलब ये 14 group में present है, तो we can call it as a fourth group. ठीक है, sometimes it is also known as fourth group. ठीक है. The maximum coordination number of carbon in commonly occurring compound is 4. Yeah, CH4 you can see, various organic compound you can see in which carbon shows valency of 4, because its coordination is what, 4 ligands can attach to it, whereas that of silicon is 6. This is due to, so why is it happening? So you know why is it happening? You know carbon does not have d orbitals, right? It does not contain any kind of d orbitals, while silicon contains the d orbitals, and that's why it can consist of, or it can form a bonding with more than 4 atoms around it, and that's why it can form bonding with 6 atoms. So that is this is happening due to availability of low lying d orbitals in silicon. This is happening due to large size of silicon. This is happening due to more electropositive nature of silicon, or both B and C. So both B and C तो नहीं है, ये भी नहीं है, ये भी नहीं, ये भी नहीं है, ये, क्योंकि क्या हो रहा है, there is availability of vacant d orbitals in its valence shell, which can be used for the bonding purpose. Right, guys? Any doubts regarding this? Right. So next problem, which of the following does not show electrical conduction? Yes, can you tell me the answer? Very, very simple. Diamond, graphite, potassium and sodium, which do not show electrical conduction. Yes, tell me. Graphite दिखाता है electrical conduction, diamond दिखाता है, potassium दिखाता है, sodium दिखाता है. उसमें से हमको find करना which is not showing, which will not show. Diamond, graphite, sodium and potassium. Yes, everyone, which will not show the electrical conduction. Answer me. पोटेशियम कंडक्ट करता है इलेक्ट्रिसिटी, वो मेटल है ना, metal will be good conductor of electricity. Sodium is also metal, it's also good conductor of electricity. Graphite is what, good conductor of electricity, but diamond is not showing the electrical conduction. Yeah, you see, A will be the answer. So here, except diamond, what is happening, the order of conductivity among these is what, potassium and sodium are metallic conductors, while graphite is non-metallic conductor. So if in a specific way it has been asked, पोटेशियम और सोडियम क्या है, मेटालिक कंडक्टर से, लेकिन ग्राफाइट क्या है हमारा, नॉन मेटालिक कंडक्टर. राइट. नेक्स्ट प्रॉब्लम, वेरी वेरी सिंपल. कैन यू टेल मी द परसेंटेज ऑफ लेड इन लेड पेंसिल? कैन यू टेल मी द परसेंटेज ऑफ लेड in lead pencil? It is 80%, 20%, 0 or 70. Yeah, lead pencil contains how much lead? यूज करते होगे ना पेंसिल, पेंसिल में कितना परसेंटेज होता है लेड का, पता है आपको? किससे बनी है पेंसिल? पेंसिल इज मेड अप ऑफ, यस, लीड पेंसिल किससे बनी है? लीड से बनी है। यस, एनी आंसर्स? ग्राफाइट से बनती। वेरी गुड आयुषी, या गुड गर्ल। सो लेड से लेड पेंसिल नहीं बनती है, ठीक है, वो किससे बनती है? ग्राफाइट और क्ले से बनती है। वेरी गुड, ग्राफाइट एंड क्ले, वेरी नाइस। सो दैट्स व्हाई लेड जो है उसमें प्रेजेंट है क्या? नहीं। So that's why our answer is what? 0. So there will be 0% of lead in the lead pencil. Actually, lead pencil is made up of graphite and clay. It doesn't contain any amount of lead. So answer will be what? Option C. Next, in graphite, electrons are localized on each carbon atom. Okay, electrons are localized on each carbon atom, localized on every third carbon atom, spread out between the structure present in anti-bonding orbital. So when I told you that graphite is a good conductor of electricity, that is, it is a non-metallic conductor. So why is it happening? Because electrons are all over present in the structure of a graphite. Okay, so when we talk about the structure of graphite, in each molecule of carbon atom present in the graphite, they undergo sp2 hybridization. Okay, they undergo into sp2 hybridization, and they are covalently bonded to 3 other carbon atoms by using a single bond. So here sp2 hybridization is also present, and the 3 other carbon atoms are attached to a carbon with the single bond. Okay, the fourth carbon or the fourth electron forms the pi bond. Okay, fourth electron जो है हमारा कार्बन में का, वो पाई बॉन्ड फॉर्म करेगा, और ये जो पाई इलेक्ट्रॉन्स है, these pi electrons are delocalized over the whole structural sheet, and that's why that is the correct answer. So here the electrons are spread out between the structure. Okay, electrons are फैले हुए हैं ग्राफाइट में, and that's why it is a good conductor of electricity. But वहां पे मेटल कोई प्रेजेंट नहीं है, and that's why it is non-metallic conductor. Right? Yeah. Next problem: which of the following types of forces bind together the carbon atoms in diamond? So what do you think, which forces are responsible in order to binding of carbon atoms in bond? Ionic bonds, dipolar bonds, covalent bonds, and van der Waals bond. Yeah. Yes. डायमंड में कौन से प्रकार के होती है बॉन्डिंग? बताइए बताइए। ग्राफाइट में all carbons are what? Yes. So in the diamond what happens is each carbon atom is sp3 hybridized. ठीक है, वो sp3 hybridized होने के कारण forms a covalent bonds with the 4 other carbon atoms. ओके, सो यहाँ पे वो क्या करते हैं? कोवैलेंट बॉन्डिंग फॉर्म करते हैं कार्बन के एटम से, यार कार्बन के मॉलिक्यूल से। व्हाट दे आर गोइंग टू डू? दे आर गोइंग टू फॉर्म अ कोवैलेंट बॉन्डिंग हियर इन द गिवन मॉलिक्यूल, क्योंकि कार्बन कार्बन को अटैच्ड है ना। किस प्रकार की बॉन्डिंग होगी फिर यहाँ पे? यहाँ पे तो कोवैलेंट प्रकार की ही बॉन्डिंग होगी। वेरी वेरी सिंपल प्रॉब्लम। ओके, विच ऑफ द फॉलोइंग इज एन इंसुलेटर? इंसुलेटर कौन है हमारा? ग्राफाइट है, एल्यूमिनियम है, सिलिकॉन है, या डायमंड है? बताइए बताइए, बहुत ही इजी प्रॉब्लम है। Which of the following is an insulator? Yes, everyone who is present in the class, can I take the names of you? You have to answer the question. Do you think which is the, first of all, what is insulator? Insulator means which is not a good conductor of electricity, which will not conduct any kind of electricity. That is the meaning of insulator. Okay, graphite is insulator? No, it is what? Good conductor of electricity. Aluminum is a metal, so again aluminum is a metallic conductor, that's why it is going to conduct the electricity. You know, there are several wires of electricity present. Yeah, Ayushi. Yeah, Priyadarshani. C. Okay, very good. सिलिकॉन इज अगेन मेटेलिक कंडक्टर, दैट्स व्हाई डायमंड इज व्हाट? एन इंसुलेटर. आपको पता है सब लोग डायमंड की ज्वेलरी पहनते हैं, अगर वो इलेक्ट्रिसिटी कंडक्ट करता तो कोई ज्वेलरी बनाता? नहीं बनाता ना. तो डायमंड very common sense here. Diamond is what? Insulator. On the other hand, all others are good conductors. Okay. Next, identify a correct statement from the following. So we have given A, B, C. So three statements are there, A, B, C, D, and we need to find out correct one. Okay, we need to find out the correct one. So here, let's read the statement. CO2 is used as a refrigerant for ice creams and frozen food. So ये correct statement है क्या? Yes, whether it is correct statement. CO2 हम use करते हैं refrigerant for ice cream and frozen food के लिए. Okay, next, the structure of C16 contains 12 6-carbon rings and 25 carbon rings. So this is again not correct. Okay, C16 we talk about fullerene. It doesn't contain 12 carbon atom rings and 25 carbon rings. Okay. Next, ZM5, a type of zeolites. Yes, zeolite होते हैं ZSM5. It is used to convert alcohols to acetylene. Yeah, this reaction is feasible with ZSM5 as a catalyst. CO is colorless and odorless gas. So again, this is true. So here, when we talk about the options now, solid CO2, which is a dry ice, is used as a refrigerant for ice cream and frozen food. नॉर्मल CO2 नहीं यूज करते हम लोग कौन सा CO2 यूज करते हैं? सॉलिड वाला CO2. ठीक है. द स्ट्रक्चर ऑफ C60 contains 26 membered ring. Okay, it contains 26 membered rings and 12 5-membered rings. Okay, हमारे पास 20 जो है वो 6 membered ring होते हैं. ठीक है, और हमारे पास 12 जो है वो 5-membered ring होते हैं. ठीक है, यहाँ पे 12 और 25 बोला था. So that is not correct. Okay. Next, C and D are the correct statement. Just I have told you, and A and B are not correct. That's why our option D is correct answer. Yes, everyone. Any doubts regarding this? समझ में आ रहा है? C60 is a fullerene molecule which contains 20 cyclohexane rings. Okay. बेंजीन उसमें 6 होते हैं. मतलब बेंजीन जैसे जो हमारे स्ट्रक्चर होते हैं ना 6 मेंबर रिंग के. ओके, 6 मेंबर रिंग के जो हमारे स्ट्रक्चर्स होते हैं उस प्रकार के जो कंपाउंड्स होंगे वो जो स्ट्रक्चर है वो कितने होते हैं? 20. और 5 मेंबर रिंग्स कितने होते हैं? उसमें 12 होते हैं. यहाँ पे गलत बताया था, 12 और 25 बताया था. ठीक है, और इनवर्स था, 6 मेंबर 12 होंगे और 5 मेंबर 20 होंगे. ओके, सो दैट वाज इन इनवर्स. सो प्लीज रिमेंबर यहाँ पे 12 दिया है और यहाँ पे कितना दिया है? 20. राइट. ओके, नेक्स्ट. Okay, next problem. Which of the following compound is used in the cosmetic surgery? Yeah, silica, silicates, silicons, zeolites. So what do you think? Which of the following is used in the cosmetic surgery? Yes, silica, silicates, silicons, or zeolite. Have you heard about the cosmetic surgery? Yeah. Which will be used? Silica, silicates, zeolites, or silicons? ठीक है, तो यहाँ पे when we talk about the cosmetic surgery ना, so silicons being biocompatible are used in surgical as well as cosmetic plants. ठीक है, तो जब कुछ भी इम्प्लांटेशन होता है, कॉस्मेटिक सर्जरी होती है, उसमें सिलिकॉन का यूज किया जाता है, सिलिका का नहीं, सिलिकेट्स का भी नहीं और जियोलाइट्स की भी नहीं. Okay, any doubts regarding this? Please try to remember this. Okay, silicons are used for the cosmetic surgeries. Next, which of these is not a monomer for a high molecular mass silicon polymer? So for a high molecular mass silicon polymer, when we talk about it, okay, so all other means 1, 2, 3, 4, we need to find which will form a polymer. तो ये जो है ये पॉलीमर फॉर्म करता है, ये पॉलीमर फॉर्म करता है, ये पॉलीमर फॉर्म करता है. लेकिन जो हमारा ए मॉलिक्यूल है, ठीक है, इट डजंट फॉर्म्स अ पॉलीमर, इट ओनली फॉर्म्स अ डाइमर. ओके, इट ओनली फॉर्म्स अ डाइमर्स. दैट्स व्हाई आवर आंसर विल बी व्हाट? ऑप्शन ए. ओके, वो सिर्फ डाइमर फॉर्म करता है, वो कोई भी पॉलीमर फॉर्म नहीं करता, इसलिए वो किसी भी पॉलीमर का मोनोमर नहीं हो सकता. राइट. ओके, नेक्स्ट प्रॉब्लम. द बेसिक स्ट्रक्चरल यूनिट of silicates is. So you know silicates, right? There are several silicates present. Okay, orthosilicates, then cyclic silicates, right? So right now, tell me what is the basic unit of silicates? SiO3 2 minus, SiO3 2 minus, then SiO4 2 minus, and SiO minus and SiO4 minus. Yeah, tell me which will be the बेसिक स्ट्रक्चरल यूनिट ऑफ सिलिकेट. या सिलिकेट्स का कौन सा होता है बेसिक यूनिट? आपने स्टडी किया है ग्रुप 13 एलिमेंट्स, रीड किया था कल, मैंने आप लोगों को बताया था. यस, व्हाट विल बी द स्ट्रक्चर एवरीवन? So silicates have the basic structure and that is what? SiO4, SiO4 4 minus, SiF4 4 minus, that is option D. Okay, SiO4 4 माइनस, ये जो हमारा बेसिक यूनिट है ये हमारे सिलिकेट्स में हर तरह से फैला हुआ है. ओके, द सिलिकेट्स आर एक्चुअली मेड अप ऑफ दिस बेसिक यूनिट SiO4 4 माइनस. एनी डाउट्स? रिमेंबर दिस. ओके, वेरी वेरी सिंपल. SiO4 4 माइनस, SiO4 4 माइनस, ये जो हमारा बेसिक यूनिट है इससे हमारे सिलिकेट्स सारे बने हुए हैं. ठीक है, ऑल द सिलिकेट्स आर मेड अप ऑफ this basic unit, right? Any doubts? Okay, next problem. Which statement is wrong? So here we need to find out which of the statement is wrong. Okay, not correct, we need to find out wrong statement. Okay, not correct statement हम लोगों को देखना है. Beryllium is an example of cyclic silicate. Mg2SiO4 is orthosilicates. Basic structural unit in silicates is the SiO4 tetrahedron. Feldspar are not aluminosilicates. So here we need to consider the wrong statement. तो अभी मैंने आप लोगों को बताया बेसिक स्ट्रक्चरल यूनिट इन सिलिकेट्स क्या होता है? SiO4 टेट्राहाइड्रॉन मॉलिक्यूल्स होते हैं. ठीक है, तो यहाँ पे ये स्टेटमेंट तो करेक्ट है. नेक्स्ट, बेरिल इज एन एग्जांपल ऑफ साइक्लिक सिलिकेट. तो ये भी जो हमारा स्टेटमेंट है ये करेक्ट है. ठीक है, नेक्स्ट Mg2SiO4, ये जो मॉलिक्यूल है ये क्या है? एग्जांपल है हमारा ऑर्थोसिलिकेट्स का. ठीक है, यहाँ पे जो रॉन्ग स्टेटमेंट है ना वो हमारा लास्ट वाला स्टेटमेंट है. फेल्डस्पार्स आर नॉट एल्यूमिनोसिलिकेट्स. सो फेल्डस्पार आर व्हाट? दे आर 3-डायमेंशनल एल्यूमिनोसिलिकेट्स. एक्चुअली दे आर एल्यूमिनोसिलिकेट. तो यहाँ पे नॉट जो लिखा है उसकी वजह से ये स्टेटमेंट गलत हो गया. ओके, फेल्डस्पार आर एक्चुअली एल्यूमिनोसिलिकेट्स, राइट? सो दिस ऑप्शन, that is this statement is a wrong statement and that will be our option here. Okay, next problem. Name the two types of structure of silicates in which one oxygen atom of SiO4 4 minus is shared. So we need to tell here which silicate contains a shared oxygen. Okay, linear chain silicates, sheet silicate, pyrosilicates, 3-dimensional silicates. So these are the different types of silicates, and among these, who shares the oxygen atom between SiO4 4 minus units? So here you can see pyrosilicates contain 2 SiO4 4 minus units which are joined by oxygen atom. Okay, so this will be our answer, that is pyrosilicates. Okay, pyrosilicates is our answer which contains oxygen in them in their structure. Try to remember this. SiO4 माइनस के जो 2 यूनिट्स हैं, SiO4, ओके, SiO4 माइनस के जो 2 यूनिट्स हैं उनके बीच में हमारा कौन आ रहा है? ऑक्सीजन यहाँ पे प्रेजेंट है. ठीक है, तो यहाँ पे ये 1 2 3 है. ठीक है, here 3 are present, here 3 are present, but when we look overall na, they contain what? SiO4 4 minus molecule. Okay, yeah. Next problem, the straight chain polymer is formed by hydrolysis of this molecule followed by condensation polymerization, hydrolysis of this molecule by addition polymerization, hydrolysis of this molecule followed by condensation polymerization, and last one. So यहाँ पे we need to form straight chain polymer. Okay, so straight chain polymer, how is it going to form is, see, the straight chain polymer can be formed by hydrolysis of substituted chlorosilanes. Okay, तो यहाँ पे आप देख रहे हैं मैंने यहाँ पे डायमिथिल डाइक्लोरोसिलेन लिखा हुआ है. ओके, सो हाइड्रोलिसिस ऑफ सब्स्टिट्यूटेड क्लोरोसिलेन्स yields corresponding silanol. Okay, this is what silanol, which undergoes into polymerization. This will further undergo into polymerization. And out of the given chlorosilane, only CH3 to SiCl2 will give us a linear polymer on hydrolysis followed by polymerization. तो यहाँ पे हमारा जो ऑप्शन सी है इसमें क्या है, सब्स्टिट्यूटेड सिलेन्स है, सब्स्टिट्यूटेड डाइक्लोरोसिलेन, एंड दे आर गोइंग टू गिव अस द लीनियर पॉलीमर. हमको लीनियर पॉलीमर चाहिए, तो लीनियर पॉलीमर हमको कौन देगा? सो सी ऑप्शन इज द करेक्ट आंसर. हाइड्रोलिसिस ऑफ दिस मॉलिक्यूल फॉलोड बाय कंडेंसेशन एंड पॉलीमराइजेशन is going to give us what? Is going to give us a straight chain polymer. Okay, linear polymer, straight chain polymer. Any doubts regarding this? Yeah. Next problem. Which of the following anions is present in the chain structure of silicates? Yeah, silicates. Chain structure जो है हमारा silicates में, उसमें कौन सा हमारा जो बेसिक यूनिट है वो प्रेजेंट है? Si2O5 है, क्या है? Si2O5N है, हाँ यहाँ पे, और यहाँ पे SiO3N है, यहाँ पे Si2O7. मतलब ये जो ऑप्शन है ये मैं यहाँ पे लिख देती हूँ आपके लिए. SO2O5 माइनस N, यहाँ पे क्या है? SiO3 माइनस N, राइट? टेल मी. तो सिलिकेट्स का जो चार्ट है ना वो आपको ध्यान में रखना है. यहाँ पे 6 माइनस और यहाँ पे है N, नहीं 6 माइनस. या tell me which of the following anion is present in chain silicate. So for chain structure of silicate, it contains 2 oxygen atoms which are shared between each tetrahedral. So anions of chain silicates have 2 general formula, that is SiO3 2N minus, this is present, as well as Si4O11. ओके, Si4O11, यहाँ पे आएगा हमारा N और यहाँ पे हमारा होता है 6 माइनस. तो इस प्रकार से हमारे जो मॉलिक्यूल में जो बेसिक यूनिट्स है वो प्रेजेंट होते हैं. तो इस कारण यहाँ पे क्या हो जाएगा, यहाँ पे हमारा जो मॉलिक्यूल है बेसिक यूनिट है वो कौन सा रिपीट होने वाला है बच्चों? देखिए यहाँ पे हमारा बेसिक यूनिट प्रेजेंट है ये वाला, ठीक है, ये वाला प्रेजेंट है. तो हमारा ऑप्शन हो जाएगा बी. यहाँ पे है क्या वो यूनिट? नहीं है. यहाँ पे है, यहाँ पे है क्या वो यूनिट? नहीं है. ठीक है, ओ क्या है? 11 है ना, मैंने ऊपर लिख दिया सॉरी, लेकिन यहाँ पे वो जो 11 लिखा है मैंने ऊपर गलती से, वो नीचे होगा. S4O11 है यहाँ पे, राइट गाइस? यहाँ पे S4O11 है. SiO3N 2N माइनस Si4O11N रेज़ टू 6 माइनस. ये क्या है? हमारे चार्जेस है. ओके, Si4O11N 6 माइनस. ओके, सो हमारा ऑप्शन भी करेक्ट है. यहाँ पे ये यूनिट हमारा चेन स्ट्रक्चर ऑफ सिलिकेट्स में प्रेजेंट है. नेक्स्ट, विच ऑफ द फॉलोइंग स्टेटमेंट अबाउट द जियोलाइट इज फॉल्स? सो जियोलाइट, I have told you. So zeolite are what? ZSM5. Okay, ZSM5. So it is made up of यहाँ पे देख लीजिए, पहले हम लोग कुछ स्टेटमेंट है वो पढ़ लेते हैं. ठीक है, दे आर यूज्ड एज अ कटायन एक्सचेंजर. दे हैव ओपन स्ट्रक्चर व्हिच enables them to take up small molecules. Next, zeolites are aluminosilicates having 3-dimensional structure. Next, some of the Si4 minus units are replaced by NO4 5 minus and ALO6 9 minus ions in zeolite. तो यहाँ पे हमको ढूंढना है फॉल्स स्टेटमेंट. तो जब हम फॉल्स स्टेटमेंट की बात करते हैं तो जियोलाइट्स क्या है? एक्चुअली दे आर having cage-like structure. They have cage-like structure so that whatever ions comes na, it get trapped into that ZSM5. It will get trapped into that given cage. तो उनका जो स्ट्रक्चर है ना वो ओपन स्ट्रक्चर नहीं है. ठीक है, उनका स्ट्रक्चर कैसा है? केज जैसा स्ट्रक्चर है. ओके, दे हैव केज-like structure. So in zeolites, some of the Si4 minus units are replaced by ALO4 5 minus and ये जो स्टेटमेंट है ये गलत है. ठीक है, और वहां पे जो हमारा स्ट्रक्चर है वहां वो जियोलाइट्स का वो क्या करता है? इट एक्चुअली ट्रैप्स द मॉलिक्यूल. ओके, यहाँ पे दिखा है enables them to take up the small molecules. Okay, so their structure is actually what? they are having open structure which enables them to take up the small molecule. Sorry, यहाँ पे मैंने cage like बोल दिया, लेकिन वो क्या है actually? It is having what? Open like structure, right? So next is what? ऑप्शन डी. ऑप्शन डी में आप देख सकते हो कि SiO4 माइनस जो आयन है, हमारा जो यूनिट है SiO4 4 माइनस यूनिट, so that is not replaced by LO4 5 minus and LO6 9 minus ions in zeolite. तो यहाँ पे Si4 प्लस आयंस जो है वो रिप्लेस होता है Al3 प्लस आयन के साथ, ठीक है, 5 माइनस और 9 माइनस के साथ नहीं, सिर्फ 3 प्लस के साथ वो रिप्लेस्ड हो जाता है. एंड दिस रिजल्ट्स इन अनबैलेंस्ड आयोनिक चार्ज. टू मेंटेन इलेक्ट्रिकल न्यूट्रलिटी पॉजिटिव आयंस मस्ट बी इंट्रोड्यूस्ड इनटू दैट. सो ये जो हमारा ऑप्शन डी है वो हमारा रॉन्ग स्टेटमेंट है और वही हम लोगों को ढूंढना था, इसलिए अवर ऑप्शन डी विल बी द करेक्ट आंसर हियर. तो जियोलाइट्स क्या होते हैं एक्चुअली? दे कंटेन एल्यूमिनियम and silicon, that's why they are known as aluminosilicates. Okay, they contain aluminum as well as silicon in it, that's why they are known as aluminosilicates. Okay, yeah, and they have three-dimensional structure, and that three-dimensional structure is open structure and it can trap a given ion into it. Okay, which type of ion? Cations. Okay, they can exchange the cations. Very good. So zeolite की information इस एक problem से आप लोगों को समझ में आ गया. Now let's solve the last problem of today's session. The substance used as a smoke screen in warfare is. So in wars, which substance is used as a smoke? Okay, smoke screen in warfare. SiCl4, PH3, PCl5 and acetylene. So what do you think which is used as a smoke screen in warfare? So here answer is what? Option E. So here SiCl4 is a molecule which undergoes into hydrolysis in presence of moist air. So when moist air is present, SiCl4 undergoes into hydrolysis, and due to which there is a formation of smoke. Smoke means what? There is a formation of white fumes in the air, and which is used as a smoke screen in warfare. तो हम लोग अगर हमको कुछ दिखाना नहीं हो वॉर में, ठीक है, we need to hide for certain interval of time, so we can use SiCl4 because SiCl4 produces the smoke, white color smoke, and due to which it looks like means वहां पे क्या होता है, वो स्मोक जैसे क्रिएट होता है और वो व्हाइट स्मोक होता है और वो स्मोक स्क्रीन जैसे हम लोग यूज कर सकते हैं. ठीक है, मतलब नॉट वी. ओके, इन वॉरफेयर इट इज यूज्ड. ठीक है, हम लोग नहीं यूज कर सकते, वॉरफेयर में वो यूज होता है कभी कभी एज अ स्मोक स्क्रीन. तो कौन सा एलिमेंट होता है, कौन सा मॉलिक्यूल वहां पे प्रेजेंट होता है? एलिमेंट सिलिकॉन और क्लोरीन, एंड द मॉलिक्यूल फॉर्म ड्यू टू देम इज SiCl4, राइट, बिकॉज इट अंडरगोज इनटू हाइड्रोलिसिस रिएक्शन. तो यहाँ पे प्रॉब्लम अलग तरह से भी फॉर्म हो सकता है. And SiCl4 is used in the warfare due to which type of reaction just takes place in that? So वो हाइड्रोलाइसिस हो जाता है उसका एयर में, ठीक है, मॉइस्ट एयर में, उस वजह से व्हाइट फिल्म्स क्रिएट होते हैं which will use as a smoke screen during the warfare, right? So that's it for today's lecture. If you have any doubts, you can tell me. Yes. Thank you so much for joining today's lecture. Yes, yeah, thank you for joining. Okay, let's meet tomorrow, okay, on the same time.